Hello. Today I'm be talking about Livy, the new project that I've been working for the last 3 months after MammothCam, and I'll be talking about building verifiable applications. So first thing, who I am. I'm Saul, one of the co-founders of Livy. Some background about me: been working on CK email before, also HP and some other things. And I'm going to be talking about an introduction to Livy and verifiable applications, our hackathon, our MammothCam project, CK Media, and basically how we build data on all of that. Then how can we simplify developer experience with the technology that currently exists? And then the best for the last, the MammothCam, the first Livy application with Celestia underneath. So let's begin with the problem that we were facing during MammothCam and why we built Livy at the beginning. So proof generation times is extremely slow. When we're trying to build CK Media, the first problem that we faced, or one of the many problems that we faced, was that generating proof of large computations, such as media files, in this case images, was taking more than 3 minutes in some cases when we were trying to basically create complex compositions and all of that. So by running with a prover network, you are going to get those results. It's going to be extremely slow. It's going to be extremely expensive. And basically, we were trying to figure out how can we do it faster. And basically, with Livy, we have built basically a solution that does the same thing under a second. On verifiable computations, we have different approaches, which is basically CK, optimistic, but also trusted execution environments. With CK, basically, we're using CK VMs to verify the execution trace, and basically with that, we create a polynomial and we verify that in a CK proof. And then with TEs, we replace that solution completely. We basically run the exact same program, and we basically achieve near native computation speeds with near to native normal computation costs, which means that we can achieve those performance. So that's the reason why we went with TE. We went with TE because we can deliver a near native performance, keeping the cost as efficient as possible. And this is extremely important when applications need to be fast, or also when they need to have extremely low latency. For example, Succinct uses TEs for verifying their proofs with a second-factor authentication, and Bana also use them for basically proving information about the users in an extremely efficient way. But how can we build applications on top of TEs with the best developer experience? So as an example, we built this week on top of Livy the first Livy application, which goals basically was to take a picture, then you verify that. In this case, you take the picture in this place, in Mammoth, New York City, and then once that's verified, we submit that proof, in this case the attestation from the TEE, on Celestia in order to have settlement. So how we do that in the most simple way possible. This is our console, basically the way we can build applications with normal code and then basically create verifications after. In this case, we have the MammothCam, which basically is the program, a Rust program that's basically creating the verification for the image that you have taken with the MammothCam. So basically, here we are going to upload an image to the application. Basically, you can develop your own logic, and then in order to verify any programming language or any program that you have, you basically create your Livy service in the programming language that we have, but only we support Rust at the moment. We're going to include all of the programming languages later on. And then once you have that created, you basically call the API proxy to basically verify the information that you have. After we have that, we get the proof. And then lastly, we just basically upload that information to Celestia. So this is pretty much how applications can be verifiable. Basically, TEs can achieve that in an extremely simple way. And then the way we're going to manage to create the best security and having basically remove trust assumptions from TEs is basically with our announcement, which is going to be a provenance layer, which basically it's going to take the attestations from TEs and the services that any developer can create with any programming language, and then basically verify that in a decentralized way with a provenance layer. So this is pretty much Livy. Thank you.
What are other potential use cases you can see playing out with Livy?
So with Livy, the main potential that you have is that any application that you have existing right now, you can upload and run it on Livy, which means that any Web2 application that already exists can become Web3 secured by running that under the TE service. The way it's going to happen is that every execution you make from your program, it's going to create a TE attestation. And this TE attestation is going to include the timestamp that Mark won't happen the execution, the inputs, the binary that has been executed in the program, and then it's going to be executed by the TE nodes, which basically are going to create the output. The provenance layer is going to associate all of this together, and any programming language or any application that you develop in any scenario, basically, it's going to be basically verified with TE proofs.
So for MammothCam, the way it is now, what are the aspects of the metadata that I can prove verifiably? Is it just location and like time, or there are other features?
In this case, for the MammothCam, we can play with that later. Basically, we're taking an image. The moment we're taking an image, we're basically taking the location from the mobile phone that's taking the photo. Then that image is getting uploaded into like the cloud. And then once we have the image, you can go to the gallery, verify that image, basically by clicking a button, which basically it's sending a request into like the Livy service. Then it's going to verify that the location, it's basically within 250 meters of this event. And then once we have that verification and this TE attestation, we are submitting that image and the attestation for that image to Celestia.
Got it. So the thing that gets posted to Celestia is the attestation from the TEE and like a hash of the image.
No, we are actually posting the image.
Oh, the full image?
Yeah.
Do you have to do that?
We could ignore that by basically uploading the hash.
Okay.
We just wanted to place on a bit more like basically, as like the blob is going to be extremely small because the application is optimized. Basically, we're uploading the base 64 encoded image in Celestia as well. Usually, and especially for a provenance layer, once we have that, especially for having a fixed size for every provenance data, it's going to be a hash of the full information. It's not going to be variable based on its execution, but for this case, we wanted to have like the original image uploaded to Celestia, plus the attestation of that execution, which basically verifies that this image was basically taken from this event.
Very cool. Thank you.
Thank you.